This is Mr. Beck Does Your Homework. This is physics homework number 5. This is questions number 2 and 3, a two-part question. Question number 2 states, an automobile with an initial speed of 4.18 meters per second. I'm going to stop right there. Initial speed of 4.18 meters per second. That is my initial speed, which I write V0 equals 4.18 meters per second. Okay, initial speed of 4.18 meters per second accelerates uniformly at the rate of 3.8 meters per second squared. When I see the units meters per second squared, I know that that is an acceleration. So my acceleration is going to be 3.8 meters per second squared. Find the final speed of the car after 5.8 seconds. Find the final speed. So I'm looking for V, my final speed. So V is question mark. After 5.8 seconds, my time is going to be 5.8 seconds. Now, do I have an equation that relates initial velocity, acceleration, final velocity, and time, but does not have distance and does not need distance and doesn't care about distance, doesn't ask about distance? Yes, I do. My first equation on the top of your homework, you'll see the first equation is missing my displacement. So my first equation says that my final velocity is my initial velocity plus my acceleration times my time. No distance in there. And I'm looking for final velocity, so this is even easier because I don't have to solve for some variable. So my final velocity is my initial velocity of 4.18 meters per second plus my acceleration, which is 3.8 meters per second squared, times my time of 5.8 seconds. So my final velocity is going to be this plus the product of these two, and that will give you your answer. The units here, this velocity is 4.18 meters per second, and I'm adding to it 3.8 meters per second squared times 5.8 seconds. Well, this is meters per second. This one is meters divided by seconds squared times seconds. Well, you can see that this seconds cancels out one of these. So the 2 goes away, the seconds goes away. So I'm going to get meters per second plus meters per second is going to give me meters per second. So the units are going to work out. The second part of this question number 3, which is part 2, says find the displacement of the car after 5.8 seconds. So that same amount of time. So as it is slowing down from a quick velocity, as it's speeding up from a slow velocity to a quick velocity, it travels some distance. So now in my next part of my question, I'm looking for my displacement equals some number. Now luckily I have 1, 2, 3, I already have 4 variables, and I'm looking for the 5th. So I can use any equation I'd like. I'm going to use the one actually without a final velocity, just in case I made a mistake here. I don't want to get both the problems wrong. So if I can use this initial velocity, this acceleration, and this time, and find this displacement without worrying about the final velocity, I don't have to carry a mistake through just in case. So the equation that I can use that does not have final velocity is that my displacement is my initial velocity times time plus 1/2 my acceleration times time squared, which is the third of your 4 equations. So now I can plug in my numbers that my displacement is my initial velocity of 4.18 times my time of 5.8 seconds plus 1/2 of my acceleration, which is 3.8 meters per second squared, times my time squared. So that's going to be times 5.8 squared. When I do the math here, this plus this, that's going to give me my displacement. Now what about the units? This is 4.18 meters per second. This is 5.8 seconds. So when I get meters per second times seconds, seconds is going to go away, leaving with meters. This, 1/2, doesn't have any units. 3.8 is meters per second squared. And this is 5.8 seconds. And when I square that, that's times seconds squared. So you'll see that seconds squared goes away. And look, I've got meters again. So this will give me units of meters. Now, with this equation, it's good to know that x equals v0t, that would be where it would be if it were not accelerating. But then when I have the 1/2 at squared, this is what the acceleration does to that constant velocity result. So it would have been here, but this is the change versus where it would have been.